here's a really interesting point here. We do have data. We do have information from like a UPS system or a PDU or what's within the data center, right? But that's not what you and I are talking about right now. It's a little bit of a different kind of data where it's beyond data center uptime, but these sensors, these optical non-conductive sensors that when you first told me about them, I'm like, hang on a second, say all of that again, because I don't think I've ever seen something like this. So I really want you to talk about this missing piece in the data center and really why this is important right now as companies and hyperscalers and even just large data center providers that are working more closely with utilities. Why do they care about this?
Yeah, I mean, the name of the game is really power quality, right? And it's interesting because when it comes to kind of sensor and metering technology, on the power side, we've been doing it the same way for 100 years, right? You're either using an instrument transformer or more recently in history, something like a line post sensor, right? Both of those pieces of equipment are electrical circuits. They are transformers that are transforming power down to a level that metering equipment or relays and controls can handle, right? Because if you put 12,000 volts across a relay, it's going to blow up, right? So those, I mean, we like to blow things up in the power industry, so let's just get that clear.
Oh my God, don't say that to me.
What's really interesting about Micatu, I know, but what's cool about Micatu is we don't blow up, right? And that's where this technology is so fascinating, right? We're coming in with that real engineering mindset of how do we do it better, right? How do we get the data we need, better data even, and make it safer and make it more reliable, right? So what we're able to do is bring in those traditional power quality measurements, whether it be voltage or current. You know, our harmonic capabilities are amazing. You know, going out into the power factor, all of those things. But we're able to do it by measuring the fields involved, so the electric and magnetic field, through optical sensors, rather than creating a real electrical circuit. So for all my electricity nerds out there, right, so if you have a current transformer, a CT, one of the most dangerous things for somebody who works at the utility is an open CT circuit, right? Because if you hit that, you're getting zapped, and you're getting zapped hard. We completely eliminate that risk. Right? If there are transients that come across the grid, right? So some anomaly in the power that's going to cause a big problem. If you have a measuring device that is an actual electrical circuit, it's going to feel that problem, right? That problem is going to go through that device and could cause a catastrophic failure. We don't feel the problem in that electrical sense. We just see the field, right? The electric or magnetic field get bigger, do something weird. And we measure it. And then we tell the utility, hey, here's what's happening. So from the data center perspective, what's really interesting is we can say, okay, there's two ways to look at it. One is, let's verify when you are consuming power from the utility, let's just verify you're getting what you need, right? Let's verify the power coming in is clean in the sense of you're getting good power quality, right? And that's how I had always thought of it, is let's verify that, which, you know, they've got standards, and most of the time you're gonna get great power from your utility, unless something is, you know, very wrong. But what we've talked about in the past is looking the other direction, right? And is thinking about, as these data center leaders have, you know, like ESG goals, right? First one being environmental, is, you know, we're building these amazing renewable facilities that are large, right? They are utility scale, and they are providing a lot of power not only to the data center, but also the communities they serve. And so why don't we measure the impact of that? Why don't we verify that it's not only clean from it's a solar field, right? But clean as in, we're giving you really good power. And there's something in the power world called technical losses. So technical losses mean it's power that's being gobbled up by things on the grid, not being used by a consumer, or it's just inefficiencies, right? So the analogy we use in the power space, which is one of my favorite beverages, beer. So if you have a beer, right, there's beer, and then there's foam. Well, the beer is real power, and the foam is kbars. So the utility has to deliver all of that, right? You guys, as a power producer, are delivering all of that. What gets billed is just the beer. The foam is waste. That's technical losses, right? So if we are measuring in your data center, yeah, right? It's great. Everybody go look up the power triangle and just type in beer, and you will get 1,000 Google hits on pictures of beer mugs and power. I know, engineers love beer. What can I say? But what's really interesting about that is that if we have sensing technology like what Micatu provides, right, and we are within the microgrid that Switch or another data center has built, we can verify that we're limiting that amount of beer foam, right? We're giving the utility in that community a good pour. And that's something where we're being more efficient. right? We're not only saving money, which of course anyone in business wants to do, but we're providing more good, clean power, right? Clean as in renewable, but also clean as in it's solid power.